The kinetic molecular theory of gases is really a theory of why gases behave the way they do. Before the kinetic molecular theory, Isaac Newton hypothesized that gases exert pressure because of static repulsion. They're pushing away from itself, and that's the pressure you feel. That might explain why balloons are round the more you put into them. But after several experiments, Avogadro proved that was inconcise, and so did Dalton, Gay-Lussac, Charles, and Boyles. So the question becomes, how do gases exert a pressure? And the current theory is that it's based on collisions. So let's clear the slate. Let's talk about what we know about gases. Well, let's start with what we know. We know that gases have lots of space between them, specifically between each particle when compared to, say, liquids or solids. Solids, all the atoms or particles are right on top of each other. Liquids, they're on top of each other, but they're free to move around. Gases, lots of free space. So gases are mostly empty space. And this is because they have little or no intermolecular forces. For the sake of this argument, we're going to say they have no intermolecular forces. There is no attraction between one atom of a gas and another atom of a gas. Zero, zip, zilch. So while we can say, yes, there's some, and you can force there to be some interactions, for the sake of right now, for the kinetic molecular theory, we will say that gases have no intermolecular forces. If you were to chart the movement of a gas, you would find that it is always moving. So gases always are in constant motion. And because they're not affected by gravity, because gravity is negligible on a small atomic scale, they move in constant straight lines until they impact the walls of their container. Now, if they impact the walls of their container, if they lost energy, then all matter on Earth would eventually become solid because they would start losing energy and things would eventually calm down till they became a liquid, and then they'd impact the walls of their container and lose energy and then become a solid. But we know that there's gases around us all the time. So not only do they impact the walls of their container because of this constant movement, but they don't lose any energy. So we call their collisions elastic. Meaning if they hit a wall with X amount of energy, they bounce off of a wall with an X amount of energy. And lastly, it's that energy that we feel as temperature. But it's not as though you feel the kinetic energy of a single gas atom against your skin, or you take a measurement of the kinetic energy of a single gas atom. You take the measurement of all the gas atoms that are in a system. So the average kinetic energy is what we measure as temperature, specifically when we're talking about kelvins. So that's the kinetic molecular theory. It has these 6 postulates to it. And that helps us understand why gases behave the way they do, why the other gas laws happen, or why the other gas laws are observable and continuing to be true laws. Take Boyle's law, for instance. The number of moles and the temperature stay constant. If you decrease the volume, then you decrease the amount of space that those gas molecules have to move, and they will collide with the walls of their container more often. And these collisions are what we see and feel as pressure. If we look at Charles' law and the number of moles and the pressure stays constant, if we increase the temperature, now those gas molecules are going to collide with the walls of their container more and push or increase the volume of the container. They're going to require more space to maintain a consistent pressure. Or in the reverse, if we decrease the pressure, we decrease the volume, those molecules now have less space and will collide with the walls of their container more often and increase the temperature. due to increased kinetic energy. If we look at Gay-Lussac's law, in order to keep volume constant, if we increase the temperature of a gas, those collisions will occur more often and pressure will increase. Lastly, if we look at Avogadro's law, in order to maintain a constant pressure and temperature, there must be a consistent relationship between the number of moles of a gas and its volume. If the volume decreases, if the number of moles increases, the only way to maintain a constant pressure and temperature is to vary the volume. And what about Dalton's law? Well, if all of these gases have no intermolecular forces and there's no attraction between them, no matter what the gases are, assuming they are not going to react with one another, the pressures they exert can be summed up, since none of them are going away and you're only increasing the number of moles of gas, because the volumes of those individual particles doesn't matter.